Greetings to all, and this is a continuation of the last lecture. Here in the last lecture we discussed what is a wide sense random process. Here we are going to discuss what is autocorrelation and cross-correlation of a random process x of t. So here x of t is a random process. Autocorrelation function, it is denoted as Rxx of t is defined as Rxx at times t1, t2, expectation x of t1 x into x of t2. So here what happens if I give an increment to the time t? If I take t1 as time as t and t2 as t plus 2, then equation 1 becomes this one. And if the random process x of t is a WSS process, then we know that the autocorrelation function is the difference of times. So equation 2 now takes this form. Rxx2 is expectation x of t into x of t plus 2. Some of the properties of an autocorrelation function. The first property, Rxx of 2 is equal to Rxx negative 2, that is autocorrelation function is an even function. Next, the autocorrelation function at 0 is expectation of x squared of t. The third one, modulus of Rxx2 is less than or equal to Rxx at 0, implying that the maximum of modulus Rxx2 is attained at 0. And the fourth one is Rxx of t2 is equal to Rxx at 0 if for some t greater than 0, then the random process x of t is called a periodic random process and Rxx is called the periodic function. The last property of autocorrelation function, limit tau tends to infinity, Rxx2 is mu x squared. Next, the concept of cross-correlation of a random process. Here we take two different random process x of t and y of t. Then the cross correlation of x and y is defined in the similar manner as the autocorrelation is defined. Autocorrelation, there we discuss the random process x with itself, correlation with itself. Here it is the correlation between two different random process. You can see the similar definitions except for the fact that it is Rxy. And some properties of cross correlation, here Rxx xy of tau is Ryx of negative tau. The absolute value of the cross correlation coefficient is less than or equal to root of the product of cross correlations, and again the absolute value of the cross correlation is less than the average of Rxx and Ryy at 0. Moreover, we say that two random processes are orthogonal provided the Rxy at tau is 0. And Rxy at tau is the product of the expectations mu x and mu y if x of t and y of t are independent. So when two random processes are independent, the cross correlation function is nothing but the product of their means. Okay. The last property of the cross correlation is if when a random process is a sum of two random process, then its cross correlation is defined as Rzz is Rxy plus Ryx plus Rxx plus Ryy. And if the random process x and y are orthogonal, in particular we get Rzz is nothing but sum of Rxx and Ryy. So as an illustration we see this problem, a stationary random process x of t with mean mu x and autocorrelation function is given. So since it's a stationary random process, mu x is a constant, and here the question is about determining the standard deviation of this random process. So using the property 6 which is above, so in this case mu x squared is equal to limit tau tends to infinity rxx tau equal to limit tau tends to infinity, rxx is given in the problem, but tau tends to infinity. So when I apply that, you will get it as 16. So from this we get mu x is equal to 4. And by the property 2 of the previous section, we have Ex squared of t is defined as Rxx at 0. So again at 0, so therefore we have 16 plus 9 which is nothing but 25. And from this we find out what is the variance, which is E of x squared minus E of x the whole squared, which is 9. And therefore we get the standard deviation of this the random process. Okay. The second illustration, here we consider the autocorrelation function of a stationary random process which is defined as Rxx 9 plus 2 e raised to minus absolute value tau. Here the question is about finding the mean value of a random variable capital Y. Capital Y is given as integral of the random process x between the limits 0 and 2 and the standard deviation of x of t. This is, we are going to find the solution to this now. Again by using the property mu x squared is limit tau tends to infinity of the autocorrelation function. We obtain mu x squared is 9, therefore mu x is 3. Similarly, again using the property E of x squared of t is the autocorrelation function at 0, we get the value as 11. Therefore, we know that the mean of this random process is 3 and E of x squared is 11. So the first question, mean value of a random variable y. So that is expectation of y. Y, you know, it is nothing but integral of x of tau, which is 0 to 2 E of x. E of x is nothing but the mean. Mean is 3. Therefore, 3 into d tau, which gives the value as 6. Therefore, the mean value of the random variable y is 6. Next, the question is about finding the standard deviation of x of t. So for that, we find the variance of x of t, E of x squared minus E of x the whole squared. It is given by mu x and E of x squared is already determined. We substitute and we get the value of the variance of x of t. Therefore, the standard deviation of the random process, root of variance, that is root 2. So in this manner we have to find, we can find out the cross correlation function of two random processes, and we also saw that the cross correlation function of a sum of two random processes is also defined. So the problems here are basically having the concepts of autocorrelation and cross correlation for a random process. Thank you.